So we are going to continue our semester exam review. So this is our part 2 video. So let's start with 26. So 26 is talking about standard form of a linear equation. Let me remind you what standard form is. Standard form for a linear equation is ax plus by equals c. Now there's a few things that we should remember. A, B, and C shouldn't have any common factors. A, B, and C should be integers. And A should be positive. So that's that. If they said slope-intercept form, let me give you that just in case. That's going to be y equals mx plus b. So this one's, for 26, is almost in slope-intercept form. If we divided by 5, it would be good to go. But they want standard form. So we want the x to come first, so add it to the other side, then the y equals the number. Now you just have to check a few things. This should be positive. They should all be integers. They shouldn't have any common factors. Well, 7 doesn't have anything in common with 5 or 12. You're good to go. Okay? Let's take a look at 27. One formula that you should really know for the test is the formula for the slope. The slope is y2 minus y1 over x2 minus x1 when given 2 points. So what I would do is label your points as x1, y1, and x2, y2, and let's stick it into the formula. So y2 is 4, y1 is negative 2, so that negative 2 is next to already a subtraction symbol, so put it in parentheses. And then we're going to have negative 6 minus 5, so that's going to be 4 plus 2 over negative 6 minus 5, or 8 over negative 11. Now it's customary to put the negative on the top. That fraction 8 over 11 cannot reduce, so there you go, that's your answer. Let's talk about finding the equation of lines. Now, we have a few different tools to work with. We know our slope equation. We know our slope-intercept equation. We know one last one, which I call the point-slope formula, y minus y1 equals m times x minus x1. Those 3 formulas are usually all you need to find the equation for most lines. There's some exceptions, but those are the 3 formulas you definitely want to know. Now let's start with 28. They have told us the m, because that's our slope. They have told us the b, because that's our y-intercept. The most effective thing to plug that into is this one, because we can put our m value right there and our b value right there, and we got it. So the answer for this is y equals 4x minus 1. That's great when they tell us that. Now, the problem with 29 is they did not give us the slope. Now, they told us the b was negative 1, but they didn't tell us the slope. So let's think about how we could find the slope, because that's what we need. Well, the x-intercept is 2, that's the point 2, 0. If the y-intercept is negative 1, that's the point 0, negative 1. We have the point-by-point slope equation. Let's use these points to find our slope. That's what we need. We need the m. So that's going to be, if we label this x1, y1, and x2, y2, that's going to be negative 1 minus 0 over 0 minus 2, negative 1 over negative 2, or 1/2. Well, now we know our m, now we know our b. Stick it into y equals mx plus b. So it's y equals m, I'm sorry, that's positive. Y equals mx plus b. So those are our answers for 28 and 29. Now I will tell you, there's multiple ways that you can find these. That isn't the only way to have done these problems, but that's just kind of what occurred to me. Okay, let's take a look at 30. Solve the system of equations. remember, we are looking for the point of intersection. When they ask you to solve a system, where do these things have a point in common? Let's look at our first one, which I'll make a red line. We're going to start at 1. That's our y-intercept. Now, our y-intercept is 1. Our slope is 2. So think about that as 2 over 1. So go up 2 over 1, up 2 over 1. Now, I don't know where my other line is going to hit. So I'm going to stretch my line out across my graph paper. Okay? Now, let's do this one. I'll make it blue. This time our starting point on the y-axis, our y-intercept is -2. Our slope is -1 over 1. That's the coefficient right there. So we're going to start at -2, go down 1 over 1, down 1 over 1. You can see that we're going to end up hitting that point if we kept going the other direction. Now, you want to physically label the answer. The answer is that point, -1, -1. So the answer is a point of intersection, -1, -1. Okay? So the answer to a system should be a point. Unless they don't intersect, then there would be no solution. Now, for 31 and 32, we're solving a system again, but we're solving it algebraically. We still want to get an xy. The first one says substitution. Let's take this and plug it into the other equation where we see y. We know y is 5 minus x. So let's make the y in the other equation 5 minus x. So take out the y, put a little parentheses, and in that spot, we're going to put 5 minus x. That's what they told us the first equation says. Y is 5 minus x. Well, now it's just an equation. Let's go ahead and solve it. So we get 2x. Let's distribute the 3. Plus 15 minus 3x equals 12. Let's simplify that left side a little bit because 2x minus 3x is -x. Let's subtract 15 from both sides. Let's divide by -1. X equals 3. Now, we're not done. We need a point. So we have to plug in back into the fact that y equals 5 minus x. And so we get a point, 3, 2. You should find a point of intersection. Now, to find the point of intersection for 32, they are suggesting that we use elimination. And to do elimination, we either want to get rid of the x's. Think about the common multiple of 4 and 3 is 12. Or we can get rid of the y's. The common multiple of 3 and 1 is 3. I like doing the y's. Now, you could have done the x's, doesn't matter. Now, we're going to do this by multiplying this equation here by positive 3 so that this one will be a -3 and this one will be a positive 3. So the first equation leave alone. The last equation multiply by 3. And then add the two equations together, because what we're going to see is these y's are going to cancel out. We get 13x equals 65. Divide both sides by 13, and you get that x is 5. We're not done. We got to find a y. Well, you can use this equation, or you can use this equation. I think y is nicer, a little bit easier in this equation. So it says that 3x's plus, I'm sorry, I'm thinking ahead of myself. 3x's plus y equals 16. So 15 plus y equals 16. If we subtract off the 15, y is equal to 1. Write it as a point. They intersect at the point 5, 1. So there's how you would solve it algebraically. So there's 31 and 32. Let's look at 33. Here is a system of inequalities. You are going to graph them kind of like you did before. This one, we're going to make it dashed. Now the reason I know it's dashed is because it doesn't have an equal to bar. And then I'm going to shade, because it's greater, the y is greater than it, I'm going to shade above it. Okay, so let me put that one on there. So we're going to start at 2, go up 2 over 1. Now I need to make it dash, so these dots are nice and helpful. And just, kind of put some more between there. And we're going to shade above the line, greater than the line. The y's get bigger, this above the line. Now let's do the next one. We're going to make that a dashed line. Now it says y is less than, so this time we're going to be below the line. Okay? And so our slope, or our y-intercept is -1. Our slope is 1, so go up 1 over 1. And I'm going to go this way to connect with my other line. Now it's dashed, so I can just make it a little. Now I want the y's that are below the line. Now I need to make my yellow shading go all the way down so you can really see what happens, because we kind of, where I made my graph, kind of got chopped off a little too soon. So technically my yellow shading is down here. Now my blue line, if I shade, would be below the line, which is under here. So they overlap in this area right here. So that little wedge is our answer. Okay, so there's 33. So sorry, I kind of went off the graph paper a little bit. Let's take a look at 34. 34's the starting graphs here. Those are horizontal lines. Both solid because of the fact that they are equal to. You have a solid line at -2 and a solid line at +4. And technically, we would shade everything in between them. Okay? Now, the second piece here, those are vertical lines, dashed at -2, dashed at +3. Now, why are they dashed? Well, there's no equal to bar right there. And then I would shade everything in between them. So the answer is this square box here, where the two highlighted areas have intersected. Now it says, using the above set of inequalities as constraints on the function, use the endpoints to find the maximum and the minimum. So let's highlight the endpoints here. So this is an end. So the endpoints of my box, the vertices of my box. So the vertices are, okay, so let me label them. So here's my x and y axis right here. If you couldn't see that, well, that's my xy axis, if I could draw it straight. Okay, that's my x and y axis. So this is the point -2, 4. This is the point 3, 4. This is the point 3, -2. This is the point -2, -2. So remember how we did maxes and mins. Write down your function. Okay, I'm going to use a different function that's listed there because I need a function of x, y. I'm so sorry. Let's use the function 2x minus 4y. Okay? So please change your function for 35. Let's use 2x minus 4y. And we're going to plug in these 4 points. Negative 2, 4, 3, 4, negative 2, negative 2, 3, negative 2. Okay. If we plug in negative 2, 4, the x's become negative 2 and the y's become 4. So we get negative 4 minus 16 or negative 20. Now let's plug in 3, 4. We get 6 minus 16 or negative 10. Let's plug in negative 2, negative 2. We get negative 4 plus 8, which is 4. And now let's plug in 3, negative 2. We get 6 plus 8, which is 14. Now, the smallest value of any of these values is this one. That's our minimum. So our minimum value is negative 20. Our maximum value is 14. So there we go. There is number 34. And 35. Now, I'm not exactly sure why it skipped all the way to 42, but okay, let's keep going. For 42, we have a fourth power that is going to distribute to each of the powers originally there. If it doesn't have a power there, remember it's technically a 1. So that's going to be 4 to the 4th, x to the 4th, y to the 8th, because the rule is if you have a power to a power, you're going to multiply. Now, please do 4 to the 4th for me. That's just 16 times 16, or 256. And then you got your x's and y's. Let's look at 43. If you see scientific notation, multiply together. Because multiplication can be done in any order, I am going to do the 1.5 times the 2.4. And I'm going to get 3.6. Now let's do our tens. If the bases are alike and we are multiplying, we keep the base and we add the exponent. 3 plus negative 5 is negative 2. Let's look at 44. To subtract two polynomials, the one in the back, distribute the negative 1 to both all pieces. So I just multiplied all those by negative 1 so that I can combine like terms. The x squareds are like terms. 10x squareds minus 5x squareds is 5x squareds. The 4x and the negative 7x are like terms. 4x minus 7x is negative 3x. And then finally, negative 2 plus 6 are like terms. Negative 2 plus 6 is positive 4. So there is 42, 43, and 44. Let's look at 45, 46, and 47. For 45, if we have two parentheses touching each other with multiple items inside, we want to distribute. Sometimes in an algebra class you call that foiling because they're both binomials. So first we're going to distribute the 3x to both of those. That's the f and the o, first and outers. That's 3x squared minus 15x. Now let's distribute the 7 to the x and the negative 5. That's the I and the L, the inner and the last. So that's 7x minus 35. At this point, check for any like terms. Those two are like terms. Negative 15 plus 7 is negative 8. So we have negative 8x's. Let's look at 46. We're going to take this and distribute it to all three terms inside. So let's start with the 5ab. That's going to be negative 15. Now our a's and b's were originally 1s. They're each going to go up by 2. So that's going to be a cubed, b cubed. Now let's move on to the next piece. A negative times a negative makes the next piece positive. 3 times 4 is 12. I have two a's that I'm putting together with 3 A's, so I'll have a total of 5 A's, and then the B's won't change. They'll be seconds. Now let's do this one. A positive times a negative that makes the last piece negative. 3 times 6 is 18. Our A's stay a second because there's no changes. We have 2 B's and 2 B's, or a total of 4 B's. Okay, let's look at 47. The key to 47, when you see that, is to write it twice and do exactly what we did in problem 45. So take the 7 and distribute it. We get 49 minus 35x. Then take the negative 5x and distribute it. We get negative 35x plus 25x squared. Now, we have these middle terms here. We can now combine them together. So we get 49 minus 70x plus 25x squared. Now, sometimes they'll put the 25x squared first to put it in descending order, but it's the same answer either way. Now let's take a look at 48. It's our last problem of our review. Let's talk about division. To divide polynomials when there are 2 terms like this, because this isn't a 1, we can't use synthetic, we have to use long division. So let's put our 3m minus 7 on the outside, our 6m squared minus 29m plus 35 on the inside. Now be very careful when you're doing division. If, like, there wasn't an m term here, we would have to account for the m term and put a 0. But we had a squared, we have an m, we have a number, we're good to go. Now remember, we're going to compare these two. What times 3m would give me 6m squared? Well, that would be 2m. Now you put it up top. I put it above the m since those match, and now I'm going to distribute. Now you distribute to both of those. We get 6m squared minus 14m. Now we are subtracting, so change the signs of both. The first term goes away. Negative 29 plus 14 is negative 15m. Bring down the next term and do it again. What times 3 would be negative 15? Well, that would be negative 5. This is going to distribute to both. So we get negative 15m plus 35. We are subtracting, so change the signs of both. This is your answer to your subtraction, and that last step will always be any remainder. This one has no remainder, so you don't have to put anything. If you had, say, a 1 down there, you would put a 1 over 3m minus 7. So that's how you handle remainder, put it as a fraction. But we don't have a remainder for this one, so that is our answer. Our answer is 2m minus 5. So there's part 2 of the review. I hope that helped you study for the semester exam. I appreciate you watching. Thanks. Have a nice day.